Hello everyone, my name is Rahul Mohammed, Assistant Professor at College of Applied Science. This is a tutorial session about the course named Introduction to Cryptography, CSSY2201. I assume you have the link for the material, lectures and labs. You will receive this link from me or from your head of department. Similarly, you will have, when you enter this link, you will have a README file. You can open this file to discover other links that may help you in order to give properly this course. A link to GitHub where you can clone all the repository, labs and material. This is the repository of the course where you can find the lectures and all the labs. It was created from replit, which is the third link that you can use also in order to test directly all the labs in an appropriate environment where all the package are installed, etc. Okay. So I'll start by giving comments about the course outline. So when you enter the link, you will find here the outline of the courses of this course. So it's a practical course, 60 hours that you can manage to give more time for a practical session than theory session. Okay, so it's about basic cryptography and how to use Python in order to implement the most basic primitives. Encryption and decryption, hashing, keyed hashing, manipulating also files, openssl also. So when we go to the requirement, you need at least a computer, a PC with a minimum. I written here 16 gigabit, but you can use less than that. Also, if you feel that your labs in your college are under a given level of requirement less than that, you can use on an online platform named Replit in order to test all the labs. Also, you may need an Ubuntu machine, but similarly, you can use VirtualBox, of course, to simulate the OpenSSL session through terminal, or you can also use Replit, because in Replit there is an Ubuntu virtual machine where Python installed on it. So you can use the Python IDE, and you can use also directly the terminal in order to directly use OpenSSL library. Okay. So this course is based on 3 books. I already have these 2 books, but the third one I lost the access of this third book. But we can deal with other book. So the first one is about full stack Python security, about cryptography, TLS, and attack resistance. The second is this is referred as text 1. I refer to this book as text 1 inside the outline. Textbook 2, it's about implementing cryptography using Python. Both books are new, 2021 and 2020. So this is text 1, this is text 2, and this is text 3. To understand for every chapter which portion of the book talk about the content here. For example, chapter 1 or week 1, it's extracted from the textbook 2, chapter 1, that talk about introduction to cryptography and Python. Okay, this is the delivery plan. We have 13 weeks, so 13 lectures and 13 lab, but they can be reduced. You see, for example, week 1, it's about introduction to Python, yani very basic Python manipulation, plus some introduction about encoding scheme, UTF-8, ASCII, and base 64. This can be done very fast if you feel that your students already know Python, etc. You can do it very fast and focus on the lab. Okay. Focus on installing Anaconda, etc., and creating your environment and installing some module that you will use, like pycryptodome or cryptography or hashlib, etc. Okay, so this week it can be constructed purely to Python, to set up your environment using Anaconda. Week 2, it's about classical cryptography or introduction to cryptographic secret communication, secure communication in general. What is symmetric cryptography? What is the terminology? What is a brute force attack, etc. It's extracted from text 2, chapter 3. And the lab is about creating a reverse encryption algorithm and using the module bcrypt to create a secure password, to hash the password using the algorithm bcrypt, and to set up a mini system to authentify a user through his hashed password, of course using Python. So you can go fast in this lecture too. In week 3, it's about classical cryptography, Caesar, how to Caesar cipher, shift-based crypto system, how to brute force Caesar, polycipher, like Visionaire, Playfair, and fine cipher. It's a classical cryptography. Also, it needs some work. This lecture, it needs some time. In the lab, you will just implement Caesar and you will try brute force on Caesar and to figure out the key, which is 3. It can be changed also, 3 or any number between 2 and 25. In week 4, it's about block cipher and block encryption modes. We'll introduce what is a block cipher, what is a stream cipher, and we'll take as an example the standard this. After explaining this, we pass to the different mode of a block encryption, electronic code book, cipher, blockchaining, etc. With this also, we need to explain the improvement of this until the preparation the new standard AOS. So there is this, there is 2 days, and there is 3 days. For the student to understand the evolution of these cryptographic standards and why they are standardized, like normalized. Lab 4 is a direct implementation of this. using pycryptodome. Of course, when you use this, you need to choose which mode of encryption you will use, ECB or CBC or anything else. Also, you can use triple this with the same library. In week 5, you will introduce the new standard, advanced encryption standard, and all of its primitive. Add round key, sub-byte, inverse sub-byte, shift row, etc. And you will use the same model, which is a pycryptodome, in order to simulate an encryption-decryption of a message or a file, a text file. In week 6 about asymmetric cryptography, and we'll give the paradigm of the problem of using just asymmetric cryptography, what are the drawbacks, and why researchers have introduced this concept, asymmetric cryptography. And we will give example of the famous RSA, and we will explore just a small example of how using RSA. This was extracted from textbook 1, chapter 5, asymmetric encryption. Also in lab 6, you will use both Python and openssl. For a lab, you will try to generate the keys of the public and private key, how to export the public key, etc., and how to encrypt and decrypt. And in openssl, another lab in the same week, about how to use openssl on the terminal of an Ubuntu machine. Or inside replit also, there is a terminal that you can use in order to simulate lab 6. Week 7 about hash function, and we will take an example of hash function, which is SHA-2, SHA-512 bit, and we will use the module hashlib for that. We'll use the module hashlib in order to test some algorithm like SHA-2 or MD5, etc. In week 8, it's about hashing with key or keyed hash and hashmark. Okay, and also the lab. It's about it need hashlib, but it need also hashmark. With hashlib, we need hashmark in order to simulate some keyed hash scenario. In week 9, okay, it was week 9 and week 10 we separated, but now it was week 9 about just image manipulation and image understanding, image representation, how we code the grayscale image, RGB image, the resolution of a pixel, the format of the image, etc. And the lab also, it was how to represent an image by and how to plot it, and how also to compute the histogram of a given image. In week 9, it's about image cryptography and steganography and also watermarking. So we'll give a small example about image cryptography, a small example of data hiding and steganography of image, and the watermarking of the image in general for copyright protection, or for integrity checking, or for data hiding. Okay, but these two lectures have been merged together and reduced. So you will find one lecture, week 9 and week 10. First part about image representation, a very short part, and the second part about cryptography, يعني applied على image and steganography. In lab 9 and 10, we will see how to represent the image, how to plot the histogram, and in addition of pycryptodome, which we can use in order to encrypt an image, we can use also Fernet, which is a new module that implement AOS. Also, we'll use cryptosteganography, which is a model to implement an algorithm for data hiding applied on image. So these 2 weeks are merged in 1 week in terms of lecture, but 2 weeks you take your time in giving those labs. Give more time to practical session than the 2 lectures. In week 11, about digital signature and certificate, the non-repudiation problem, digital signature generation, the RSA digital signature, the DSA also, the DSA digital signature algorithm, and also the format of the digital signature X509. This lecture was extracted, was built from 2 chapters inside textbook 1, chapter 5 and chapter 6. And it contained 2 parts in its lab, using openssl in order to parse, in order to download a certificate and to parse it in order to be able to read it as a human being, because the certificate is coded as a most of the cases base 64 format. Also, there is a Python lab using cryptography module. Inside this cryptography module, we use hazmat submodule in order to create a signature as a sender, and the receiver will try to parse it. Week 12, about key management of symmetric cryptography. Key management, how to distribute the secret key, how to distribute the secret key to the interlocutor who will use DES or AOS. So they need to pre-share a key before sending, before encryption and decryption. For example, we'll see 3 paradigms: the use of Diffie-Hellman, or the use of digital envelope, or the use of a key distribution center. It's seen in this lecture. In the lab, we will simulate Diffie-Hellman, and we'll implement a simple public key infrastructure and use it. And the last week, it's about exchanging secure data inside your network, inside your 2 nodes. It can be done inside one PC by taking 2 terminals, or it can be done using 2 different computers, 2 different nodes. Because we will use sockets. In this example, we will use sockets, UDP sockets, or you can use TCP. The lab is implemented using UDP through the module socket in Python. So, and this lab this week is a pure practical. No lecture in this lab. You just try to introduce the concept of socket and use it. For the assessment, we proposed to have a project that can be presented from week 2. You give the student some access about what should they implement. It should be implemented using Python. They need to choose, for example, image cryptography or image watermarking. Or maybe they can implement themselves a simplified version of DES or simplified version of AWS. It would be a good idea also. And they will present it in the last, or say in week 14 or week 15, they can present their work, Python program, and they should present it using a PPT or something. Okay. I think no need for a report, etc. You let them the time to code and to present their result. With the project, we have practical exam 1 and a practical exam 2, dispatched in week 5 and in week 12. Of course, plus a midterm, okay, plus a final exam, which will be a theoric exam. Okay. In terms of labs, you need to implement, for example, if I go with you through the lab, you will see a lab manual with 13 labs. First lab about installing Anaconda. I advise to use both local machine and online platform, the online ID. They use Anaconda with their, they can choose a local ID like VS Code, and they implement their lab there. And also, they may use replit. I advise that they use both methods, because in big projects they need to install their environment in their machine. Okay, and also for interoperability and to be able to see to modify their code, whatever be the location. If they don't have a laptop, they can use any computer, and they access their space, a replit repository. So they need to see both methods. So for the first lab is about installing Anaconda. You can go to Anaconda and install the last version. You install it in your machine. After installation of your machine, you open the navigator. Navigator, it can facilitate creating environment and starting IDE, etc. And installing modules, because we need to install many modules. If you have followed this tutorial from the beginning, you will install many modules like pycryptodome, bcrypt, cryptosteganography, etc. You need to create your environment. Do not work on student. They should not work on the root. They need to create their environment. I already create an environment for myself, for example. For them to create an environment, you just type. You just go to this button in order to create, because navigator, it facilitates you create an environment. You can name it any name, but you need to choose the Python 3.8, the version 3.8, because it's the same version in replit nowadays that we are using. So we need to install the same version of Python, and you click create. It will be created. After creation, you will find all the modules that already installed. When you need to install another module, for example, let me go through the lab again. Here we will install Anaconda. For example, here to use Jupyter Notebook, you can use Jupyter Notebook, which is an interactive and web-based Python for lab 1, because they need to use an interactive Python in this lab. And they give the command and Jupyter give them the result of this command. Okay, it's an interactive interpreter of Python. So they can use Jupyter Notebook. You can find Jupyter after installation. You go to your environment and you go back to home. You will find Jupyter, and you launch Jupyter, and you can create. You can go through lab 1 or lecture 1. For example, lecture 1. And you test this code. It's an interactive, very fast. You can create a new file, for example, new file, and you type your code, hello world, etc. Shift enter for the execution. For example, B5 C is equal to A plus B A is equal to, what are the variables? C plus B. Print for me A. Okay, they can use Jupyter because in most of the interactive Python there in Windows, because you can save this also. You can save this work. You can save it as, for example, lab 1 test. Okay, you can save it. Okay, so if they take more than 1 week in order to make the lab, they can go back and start from the point they reached. Okay, that's it for Jupyter. Also, yes, I have done this. So they can use all of this example, this tutorial, in order to refresh their memory, because I think in colleges they already know Python. They came with known Python, so you can go fast. But in case students they do not know yet, they haven't used Python. Fresh students, semester 1 and semester 2 student and semester 3 student, they do not know Python, so they will need this. If you need an IDE, a local IDE, I advise to install VS Code. Also, from your environment, you launch this VS Code. You launch it, and the IDE will open in your environment, in the specific environment where you have implemented all the modules that you need, not on the root. So it will be open inside your lab. Control. There is a problem. So when you install VS Code, it will be installed inside your environment. Okay, you see here. For example, if I open lab 2. Lab 2. It's about bcrypt, about hashing. We'll go later to lab 2, but this is the navigator, and this is the IDE that can be installed inside the local machine. But also you can use another IDE more appropriate to you if you feel that way. Spider or P#, both can be installed through navigator. Okay. Okay. Lab 2 is about creating. There is two parts. Part 1 about creating a reverse encryption function. This is the skeleton of the function. They need to write this code, and they need to complete this code. Okay, they need to complete it here. They complete the while, complete ciphertext, etc. They complete here, etc. So in order to reverse a plain text. Part 2 it's about using bcrypt, a mini platform, in order to authentify a user by his name and his password. The authentication will be made by comparing two hashes. The hash that has been stored when a given user has created his account, his name and his password, and the other hash is when the user will enter. Okay. So we need to install two modules, bcrypt and getpass. When I go to replit, because I already give you, they know already where to go for the repository replit. If I start from the beginning, imagine that I don't have replit. I will give you this link. Okay, I will give you this link, which is the same one. Okay, this one, it's the same one. This one. But I will use another account and open another navigator browser. I will go to replit. I will create an account with my other so I have created another account here. I will use this link that I have given you in order to access the conda. So this is the replit of the course. Okay, this is the read mode, this is the view mode. You can execute the Python file, which is executed by clicking the run command, and also you can see the files. Take time to load. Take time. Whatever, you can see the file from here, and also, which is important, you need to fork it. You need to make a copy of this repository. So fork it in your space. You can give it another name, okay, or you can keep this name that I have given. So fork it inside your space. Now you can modify anything in this in this repository. It's for you. You can use it. You can share it. Okay. And it came with all the environment, all the modules that we need in order to skip. Okay, it came with all the labs that has been created. Not only that, there is the module, the packages that has been installed before in order to create. The students need to redo this. Okay, they just take the link in order to see the working example, but they need to create their environment by themselves, whatever it be in this platform, in Replit, or in Anaconda, or using VS Code. They can use this. They should replicate create an environment and importing all the needed packages. Okay. You see this package, for example, bcrypt is already installed. If it is not installed, I will search on this package using this package manager, the integrated package manager of Replit, and I will install it. Okay, so but it's already installed here, so I don't need to install again. If I want to execute lab 2, where is lab 2? Lab 2, yes. Okay, lab 2 has two parts, question 1 and question 2. I'm interested about question 2. You will click run, no? You will click run. You see here, the run command has executed another file. Why? Because the run command point on a file in which is lab shell console, which is lab 9b, not lab 2. Why? Because in the configuration file that you can access through hidden file, show hidden files, you will find a file named replit, where he point to lab 9b. When I click to the run command, it will execute lab 9b. So for me to execute lab 2, I will change this lab 2 point, run for me lab 2, and the entry point is lab 2. Okay. Now when I click run, let me click to something else before clicking run. When I click run, it will execute lab 2. Yes, now it's executed. See, this is the reverse. Cipher. Remember that lab 2 part 1 is about creating a reverse cipher. Where is lab 2? This is part 1. If you want to keep a secret, you must hide it. And we have created this reverse cipher in order to reverse all the characters if you get it, etc. Question 2, because I'm interested in question 2 now. It's about giving a username. Given a username. Oh, what I have done. And given password. Repeating the password where he will compare two hashes, and if the two passwords are matching, he he will generate a salt. He will write your username. He will generate a hash password with a salt, and he will store both the three in a file named test hash, where you find it in the same folder. Test hash, test hash, test hash. It's here. See, this is test hash. This is what I have. What have been written now, because these two have been written before. Now I have written this username, and this is the hash of the password. This is the hash of the password, and this is the salt used to hash this password. Okay, it's working fine. Okay. Imagine let me remove this now, because I need to show you from the student point of view, because as a teacher you will have this link, with the environment, etc. But the student, they need to create their own REPL. When they create their own REPL, they need to choose, of course, Python. They need to name it something. For example, okay, and they create this REPL, this new REPL. This is the tutorial, etc. It will be created a virtual machine. It's an Ubuntu virtual machine. It will load, etc. It came with a by default file named main.py. This is a configuration file in order to follow all the modules that you have installed. As you see, there is no package installed. Okay, this is basic packages installed with your repository. Okay, but when I try to test lab 2, where is lab 2 now? This is lab 2. I will test question 2, yes. Imagine that I am a student. I have written all the code as per the lab, which is written here. All the skeleton is given. Okay. I write my code, etc. When I need to test it, I make run. He will try to install by himself bcrypt, because package manager of replit will try to test by to install by himself what you need as package, because he has read import getpass, import bcrypt. They are not installed, so he will install it automatically. Sometimes it works like this, but in some other times they will not work. You need to install it by yourself. Okay, for example, now it's working. It's working. If I need to install another package, for example, pycryptodome. Pycryptodome is not installed. Okay. If I test lab which one? Yes, lab 4. I will take lab 4. I will try to see if the package manager of replit can install it by himself. This one. Control-C, Control-E. Okay, I will use another file. Okay, in the same REPL, try to instruct your student that they should create their lab, all their lab in the same REPL. Okay, better. to find all their work in the same place. Now, if I click run, of course, I need to change the hidden file, which is a .replit file, in order to, in this case also, he's trying to install pycryptodome. Good. In some other time, he will not install it. I want to show you just how to implement package using this. I will admit that he will not be able to install cryptosteganography. Just a minute. Let us test if this package manager can detect cryptosteganography. Control C. I go to the package manager. I look for cryptosteganography because I need it in lab 11. So he found it. We need to install this. Okay? One package. Yeah, I get it. Because I have already uploaded a REPL where all these models are already existing. But in your case, if you don't find this model, you need to install it this way. In your local machine, it's the same case. For example, when we need to install bcrypt, which is in lab 2. This is lab 2. I have opened it in my space here, in my local machine. I need to run this in my environment. It comes an error, no module named bcrypt, because it's not installed. You can verify this in the navigator, environment, bcrypt. See, it's not installed. In the installed module, you can browse all of the module. It starts with B. It's not there. Okay. If we want to install this module, we need to write his name here, bcrypt. You see, he found it. We click for his name and we apply this modification in order to install bcrypt. So apply. We just fetch the library. Okay. Now bcrypt is installed. You see, it's in the installed module. You can find it now. Okay. Now I can go back to my code and try to execute it again. See, it works. It's working. Okay. I type name, Barak, for example, password, salute, same password. He will compare hashes and he will write the result, name, password, hashed password, and sort in a file named test.hash. Test.hash or test hash. Store info, it used a file named test hash, yes. Test hash. See, this is the only username I have used here in my machine, Tarak. This is the hash and this is the salt used to generate this hash. Similarly, when I try to install another module, use it in lab 5 or lab 6 or lab AWS, for example, or this pycryptodome. I mean in my machine, not online. If I need to work in my machine, this is the file. If I try to install to run, there's an error. No module named crypto. Yeah, we know that this module is existing in the name of the module is pycryptodome. Okay, so we need to install it. We can do the same. We can do through Anaconda navigator because it facilitates. Yeah. I search on the non-installed pycryptodome. You see, I can install it from this navigator, or in some cases we need to choose a specific version. Okay, you can use navigator also, but you can use the conda command. For that, I need to go to the internet to see what is the command that I should use. Cryptodome. How to install it through conda, which is the Anaconda command. Conda. You can use navigator of Anaconda, or we can use the Anaconda command. If we use one of these for command, it will be installed. So I will use first one, and I go again here in my terminal. You need to be sure that you are using your environment that you have created. You need to use conda activate cryptolab, because when you use VS Code, when you launch VS Code through the navigator, it will be automatically load your environment. It will activate your environment automatically. That's why I'm advising this to minimize manual manipulation. So better to use this way in order to facilitate the task. So my environment is activated, which I named cryptolab. You need to install this inside your environment. So I will pass this command conda install pycryptodome, and he will fetch all the package needed by pycryptodome to be installed correctly. Just wait a minute. Some environment. So doing things using conda command or using Anaconda navigator are the same, but sometimes conda is more efficient. Okay, Anaconda navigator need to be updated sometimes in order to fetch the correct version of the module. Must wait some moment in order. He's searching the right repository for this. Which command? And now I discovered a replit package manager is more powerful than Anaconda in terms of detecting packages. because the installation of the module in replit most of the time automatic. If the module is common, use it will be installed automatically when you call import. Alhamdulillah, we find yes. Some packages need to be updated. Okay. It has been installed. Let me, before testing this code, go back to navigator and I check if it is installed really. I update the index through conda. My navigator. Pycryptodome. Yes, it's installed, but I have installed using conda command. Okay. Okay, let's run. So it's working as per the description of the lab. It's working. Okay, what else? In terms of installing, all of this can be done easily. I will go back to openssl, but first I need to install another package locally. Yes, this one. No, not pycryptodome. Cryptosteganography. Let's test it. It's lab lab 10C. Lab 10C part C. Let's run it. See, no module, name it cryptosteganography. I'll search on this module inside the navigator first. If I found it, it's okay. See, it's not there. If I try to find it using conda command, the same conda command that I have used before, cryptosteganography. Unfortunately, there is no record for this. Maybe it's a new module. Okay. What is the solution in this situation? Of course, the official repository is PIP. Py. not install, I need PIP cryptosteganography. Yes, there is a record for that. You see, we have the official PIP. It's the the command used by the package manager in order to install or uninstall packages. All of the model you will find the record here, but I used conda distribution. Okay, I used Anaconda as a Python distribution. So sometimes there is some model that are not updated there, okay, in the conda. In that way, only in that situation, you need to use PIP. So I copy this and I passed in order to install cryptosteganography. So I find it. It needs below. Install it successfully. Now I run. It's okay. It's working as per the lab description. Okay. This is about installing module and setting up your environment because it's very important in order to success all the labs. Finally, I will use openssl in some of the labs. I will use openssl in 2 labs actually. Of course, as we have said, you can use Kali or Ubuntu in order to access openssl and use directly the terminal as described by the lab manual. Or you can use replit. Replit, he already has a terminal. Why we cannot use it? We can use it because it's an Ubuntu machine and openssl is there. And even if it's not there, you can install it. It's like an Ubuntu machine. Okay. So this is it. I can create 2 shell, two terminal here. What I need to do now? I need to go back to the lab to see what I want to install. Where I use openssl, I think I use it in part 11. Yes. I import SSL and I can parse it. For example, this lab 11 part B. Lab 11 part B. It's a simple liner code, import SSL, address the site that I want to import from its certificate using because it's using the certificate, so I need the port 443 and it's certificate used to secure web server. So I need, for example, you can use any website and I can extract the certificate using this method from the module SSL. Then I print the certificate. For me to test it, of course, I can use the run command, but if you want to use the run command, you need to change that hidden file in order to use it. Okay, where the replit command, you change this file to say when I click run, execute for me lab 11 part C, or no need to do that. Let me come back to lab 11 part C. Yeah, part B. I go to run this command directly because it's an Ubuntu machine, so I can use a shell command in order to do that. Python and the name of this file, part B up, and run, and it will be executed. You see here, as the lab part 11b is about extracting a signature and printing to the user. It's printed, of course, here in base 64 code. In order to extract useful information from the certificate, we will execute Python lab 11, and we write the output inside the file. Okay, inside the file, and we write the certificate inside the file, and we name it, for example, wiki-crt. So we type this in the terminal. I don't need VirtualBox. This, instead of directly displaying to the user, I write it to a file. The file, because I have already done this, I'll change the name of the file in order to create a new file. Wiki and run. Now it's written. Let's go to the lab, to the file explorer. This is wiki. See, so I can use mix of Python code and shell. Also, I can extract useful information. We have said that it's machine readable, so we need to, for example, write the certificate in a human readable format. You can use this command, which is in openssl. So openssl is already installed in every Ubuntu machine. So I will write this command here. Of course, the name of my certificate is wiki2 openssl informa x509. The input option in is to specify the file from where you will read the important field in the certificate. Text, human readable, and another option, no out, without output, and this pipeline. Okay. And this is it, the certificate, version 3, serial number, signature algorithm SHA-2 with RSA encryption, the algorithm that has been used to 1 minute. So this is all the fields of the certificate. The public key, RSA, the module, the name, etc. of the subject, the authority, the certificate authority, etc., the hash, the fingerprint, etc. Okay, so this is it. You can do that inside your replit. No need to use a virtual machine, using a VirtualBox or Open or VMware. Okay, there's another lab using openssl, which is in lab. Which lab? digital certificate, yes, this one. When you try to simulate two users, they will generate both their public key and their pair of keys. They will exchange the public key and they will encrypt, decrypt, etc. You can do this inside a virtual machine with two terminal, or using two virtual machines behind an internal network, or in a bridged network, or two real machine communicate, two Linux machine communicating together inside your lab. But also you can do this inside your replit. No need to use a virtual box. So we simulate. We have two terminal. If you don't have a terminal, you can add it from here. See, you can add another shell from here, but I already have here. Okay. Oh. The lab talk about two terminal. I have already seen this. It talk about creating two directory. Better I will use the other account. This is the shell, and this is another shell. This is the shell. Okay, we put it here, and this is okay. One. It's not working. Let me see this. Just not switch. We need a new tab. Shit. Okay, do not choose switch to tab. Choose tools shell from the tools. Create for me a new shell. Okay, this is a new shell. So we need to create two directory. This is user one, and this is user two. The top one is user one. We name it Alice. The second is Bob. So Alice will create a folder. So it's created. You see. Bob will create his folder. Now, if I go back to the lab, we use the command openssl to generate a pair of keys, and we'll output this pair of keys inside the file named kpair A for Alice and kpair B.pem for Bob. Okay. Alice, well, this one is Bob. OpenSSL. We'll use gen RSA output. We name it can name it any, but okay, this one is Boba. Okay, Bob. Dot pen. And a key is created. Similarly, I make a before creating a signature, we move to Bob folder, and inside this we need to create a signature. So the signature, not signature, the pair of similarly Alice, we move to Alice, and what I need to do, I need to create a pair of keys, RSA, and I name it K Alice, for example, dot n. And this is it. It's created. If I cat it to display, cat what? The name is K. Tab. So it's here. Okay, this is the K of Alice. The K of Alice. Okay. And this is the K of Bob. Okay. Bob. And this is the K of Bob. See? And now you can continue giving them instruction in order to continue in order to extract, to export the public key, etc., to exchange, etc., and to encrypt the text using RSA, encrypt and decrypt, etc. This part is for RSA. That's it. That's all what I have to present in order to facilitate your task in this new course, Introduction to Cryptography. I hope all the material is clear, and if any problem arise, please contact me. You have already my contact in the README file. Note. Let me see. Yes, you have already my contact in the README file. So you can contact me for any feedback, for any improvement you see, for any bug that you may face in the labs, or error in the lectures. We are a team, and we are open to improve this material. Okay, thank you for listening, and see you inshallah.